Okay, please note we are recording. All right, so today and the next week, Tuesday, today is Wednesday, we moved our lecture because of extenuating circumstances yesterday to today. So next week, we're going to meet on Tuesday as usual. So today we're going to begin to talk about time series data. Okay, time series data. As you know, I mean, events occur every day, every hour, every minute. And, we the data that we collect in statistics on a time, on a time basis will be at the end of the day, how many units were sold. It could be at the end of the day, what was the average price of goods? What was the closing price of goods? Okay, if you think about, say, the oil market, you think about stock prices, we can actually ask ourselves, what was the average stock? I mean, what was the average price that a particular share of stock sold during the day? What was the beginning price? What was the closing price? We record these kinds of things very often on a daily basis. But sometimes we also take monthly data. We can take monthly average. We can take a monthly total. We can take, the beginning price at the month and the ending price at the end of the month. We collect all these kinds of data, but on a time frame, okay, on a time basis. For example, daily, weekly, monthly, hourly, we can actually define our unit. It could be an average, it could be an absolute value, it could be a total. For example, how many tons of wheat were sold today? How many tons of wheat were sold at the end of the week? Okay, and so we collect that kind of data. And so that kind of data we call time series data. Now, time series data, has its own characteristics, okay? Has its own characteristics. One of the characteristics of time series data is that the whatever value you are measuring, you can measure totals, you can measure averages, you can measure beginning and end. They kind of like fluctuate a lot, okay? Because activities in nature can fluctuate a lot. I mean, if you think about, say, how many pounds of chicken were consumed by people at the end of the week, and you look at it from week to week, you will see quite a bit of fluctuation. And those fluctuations will be based on, fluctuating changes in prices. It will be also fluctuating changes in taste, all right? And those fluctuations can also be dependent on I would say, events in nature. For example, at Christmas time, people might buy more steak than they would buy at other times, because Christmas time is festive time, and so people will buy more expensive foods because they want to celebrate. Or people will buy more clothing, okay, at Christmas time, because people are going to attend events, and so they buy more clothing. A number of things are okay. You can look at it at different times. People might buy more gasoline because there's a lot of traveling going on, and so certain seasons of the year would see a rise in the quantity of a good purchased and a fall in other quantities. Okay, because then if you have limited income, let's say you have limited income, and so you decide to allocate your income to those things that you expend your income on during particular seasons, in all likelihood, you're going to also cut back on something else because you have essentially changed your priorities, or you have modified your priorities, or you have adjusted your priorities to reflect, what your preference is, dependent on a season or dependent on, other characteristics of nature that essentially determine how you behave. So I'm going to pull up some PowerPoint slides, and I use them to explain the way we try to deal with time series. And there are certain problems that arise, okay? Because if you have fluctuations, you want to be able to predict if there is a trend in the fluctuation. That is to say, is there some kind of indication? For example, if you think about the quantity of meat consumed during the last 50 years, you might say there's a trend because population has been increasing during the last 50 years. And so this is why there's more quantity of goods consumed. Now, again, even though there's a trend, say, in the population that has been causing the increase, characteristics in decision-making by human beings could also affect the way the trend goes, okay? It could also be, trends in prices are changing, and so adjustments are being made. And so you ask yourself whether the trend that you are seeing is dependent on also trends in prices or even trends in changes in taste, okay? For example, as you can see, the price of oil could have a trend, which reflects not only a trend in population, because now there are more people using fuels, but also reflects change in trends in prices and reflect changes in trends in technology, because we are looking at alternative fuels and people are adjusting to other kinds of fuels. And we're going towards, say, a green environment. And so we begin to use solar energy. And so in as much as there's an increase in trend, shocks do occur in the system that would also explain the underlying, explain the factors that cause trends. So how do we deal with them? Okay, so I'm going to pull up some PowerPoint slides. I will also pull up some data to illustrate some of the points that I'm going to be making. Okay. All right. I mean, what are some of the things that we're going to be dealing with here? For example, I want you at least at this basic level, because this week we will just describe time series data in general, how to deal with it. Next week, we're going to address a particular method of dealing with time series, which is not the only method, which is, as a matter of fact, the most basic thing we try to deal with when you're dealing with time series. I mean, there are highly sophisticated methods. In fact, dealing with time series in itself, it's an entire area of specialty in regression analysis. Okay, so, but at least for now, we're going to be able to define and describe components of a time series. We'll lead you actually maybe even next week on how to smooth a time series, or even this week, by computing moving averages. Okay, we will not talk about computing a weighted moving average. Okay, dealing with weighted moving averages could be somewhat involving, but you generally understand what a weighted moving average is. Next week, we're going to use regression analysis to fit a linear trend, and then to also test certain characteristics of linear of time series data, which is really problematic in dealing with time series data, but also you understand exactly what it is. This is the most basic form of testing time series data. Now, the whole idea in testing time series data by this methodology is to actually determine whether the time series is stable or whether it is unstable. And if it is unstable, then what do we do? Okay. And so I'm going to actually, we're going to do the most basic thing, which is to do what's called a Durbin-Watson test. Okay. But we do other, more serious tests on time series, for example. Then once we test for stability, there are different methods of testing for stability. And then to determine how to actually use time series data for estimation. For example, if we test for a stability of order 1, we test for stability of order 2, we can actually use what we call distributed lag models. We can use what we call a Dickey-Fuller test to test for unit root, and the unit root essentially tells us whether the time series is stable. And then we also find the order of the stability. It could be an order of 1, it could be an order of 2, it could be an order of 3 to test for stability. And so there's just numerous different methods, but we will not go through them. The only thing we're going to test here is for autocorrelation. And we will explain why testing for autocorrelation is very, very important, because if data is autocorrelated, then your estimates might actually not be very useful. They could be misleading. And then if data is autocorrelated, then how do you go about correcting for the autocorrelation? Okay, this is another step. How do you go about correcting for the autocorrelation? And then correcting for autocorrelation can be done using the moving average method. It can be done using what we call a distributed lag model. And I mean, it's just complex, okay? All right. Now, when you collect data on a time series, okay, the first thing that you ask yourself is, what is the secular trend? Secular trend is asking yourself whether the trend is going upwards in a stable way or going downwards in a stable way, okay? And I'll give you an example of something that I've actually done. I look at terms of trade. Terms of trade. What is terms of trade? Terms of trade, like say between advanced countries and developing countries, okay? Now, you can look at terms of trade in a different way. Let's take something like an import price index. Import prices. When, and then export prices. When developing countries sell goods to advanced countries, what is happening to the average price at which the developing countries sells to advanced countries, okay? You can see that, for example, the price is tending downwards. But even if the price is tending upwards, the price of goods that the developing countries import, okay, from advanced countries could also be trending upwards, but at a faster rate. So what you see then is that the terms of trade between advanced countries and developing countries is such that the terms of trade against developing countries is going downwards. And so you can see a secular trend that is going downwards, okay? Or you can actually look at, say, the price of oil and say, what is the secular trend? Is it going upwards or is it going downwards, okay? And the price of oil could be going upwards, it could be going downwards, say during a particular year or over years, over several years. And so we try to estimate the trend, the long-term trend. And then we also would like to learn more about cyclical variation, okay? Certain things, like I say, vary by cycles, okay? For example, cyclical variations over spring, fall, and summer and winter. Okay, and so a good example will be employment in the construction industry. Employment in the construction industry, could be cyclical. Okay, and then we have seasonal variation. I think seasonal variation is what I was really referring to over time, but cyclical variation could just be arbitrary rising and falling. Okay, and that cyclical variation could be occurring over years. But seasonal variation is variation that occurs within a year. Okay, say between spring, fall, and summer. Where, for example, airlines, for example, are very much interested in seasonal variations because people travel more at certain times and travel less at other times. And you can see also that prices of airline tickets also change with the season. Okay, so the first thing we talked about was a secular trend. As you can see in this particular example, the number of associates at Home Depot, okay, from say 1993 to 2012, you can see it's going up. Okay, it's in the positive direction. Okay, and so you can do a regression line that shows it's going up and ask yourself at what rate is it going up. Okay, and we're going to try to estimate that, and I'm going to set up a model next week so that you can see how to actually work with this. Sometimes to make it smoother so that you don't have all this fluctuation. Okay, so this is what we call a secular trend. That is, in what direction is it going? It could be going negative, it could be going downwards, it could be going upwards. All right. Now, this is a cyclical variation. Now, this cyclical variation could also show a long-term secular trend. But the point is that the fluctuations occur over a long period of time. It's not about season. It will be something that occurs over years. For example, the economic system has a cyclical variation. So after, say, every 2 years, there is a recession. And so the economic system goes down, okay? And then it begins to go back up, okay? And then begins to go back down, and then begins to go back up. And these cyclical variations could take several years. It could be something that occurs every 5 years, all right? For those of you who read the Bible, you remember the prophecy of Joseph when the Pharaoh asked, he had this dream that, suddenly some fat cows became thin, and then the thin cows became fat again. And Joseph said, I know what it is. After every 7 years, your cows will diminish, and then after another 7 years, the cows will grow back up. Okay? That was just somebody that understood the meaning of cyclical variation. So you are going to have 7 years of famine, and then you're going to have 7 years of prosperity, and then you have another 7 years of famine, and then you have another 7 years of prosperity. This is a cyclical trend in the weather condition. And that cyclical trend could also affect agricultural produce and could also affect livestock because there is a cyclical trend in, say, insects that bite the livestock. And so when those insects multiply a lot, then the livestock will fall prey to disease and infections and viruses. And so you have a cyclical trend. And like I said, the cyclical variation would actually occur every 3 years, okay, rising and falling. And so what you see, though, is that in spite of the cyclical variation, there is a long-term secular trend, okay? There's a long-term secular trend in the sense that things are going up. All right, there are seasonal variations. And seasonal variations, during the year, I mean, could still show a long-term trend, but what you see is that the variations are actually the cycles, because this is a cyclical thing, but this is a short-term cycle over a particular, say, a year, but you're still seeing a trend going up. But even as the trend is going up over the next 30 years or 40 years, within each year, there are seasonal variations, but the trend is still going up, okay? All right. Of course, there are irregular variations, okay? And those are very difficult to deal with when we are doing econometrics. Okay, or when we're doing statistical analysis. Let's just stay with the statistical analysis, but this is just one aspect of statistical analysis, and the regression is what we use. But the first thing that we do with time series data is to try, for example, to smooth out the time series data, because those fluctuations actually make it difficult for us to fish out, to identify a trend, and to really use the data in the productive way. So one way that we address the problems of fluctuations and instability in time series data is what we call the moving average method. Okay, the moving average method, and the moving average is not anything difficult to do. And I'll give you an example of moving averages that I have worked on recently. Think about COVID, the COVID virus. How many people are infected with COVID every day? So during the last 3 years, since 2020, I've been collecting data on COVID. And I collect it on a daily basis. And so you think about 365 days a year from 2020, March or April. And so every year I have 365 points of data. And so right now I have pretty close to 1,300 points of data. And so I collect this every day. But what I observe is that there are 10,000 infections yesterday, and then there are 6,000 infections today. Then tomorrow there's going to be 12,000, then 14,000, then 18,000, and then it drops back down to 6,000, and then it goes back up again. And so from, say, March of 2020 through December of, say, 2020, or even March of 2021, I saw a long-term trend, okay? And so let's go back to this. So the secular trend was linear going up between March 2020 and March 2021, okay? And so you had a secular trend that was going up. And after that, the secular trend began to go down, okay? But with the kind of data like that you have in COVID, you couldn't say that we were looking at a cyclical variation, because COVID is not permanent. COVID is not permanent. COVID is not something that has been there for centuries. And so when I'm looking at the COVID data, I'm looking at, say, a period of 1 year, period of say from March 2020 to April 2021, and then from April 2021 to April 2022. So I see, first of all, a long-term secular, a secular trend with fluctuations, essentially with fluctuations, but a long-term trend that was going up. Now, from 2021 to 2022, then I see the secular trend going down, but still there was a lot of fluctuation, okay? All right, so now what I have done is when I'm looking at a period of say 3 months on the COVID data, I use a moving average to say what was the average rate of infection for COVID over a week. So we use the moving average method. And the moving average method is very simple. It's a very, very simple method. Let me see. I'm going to stop sharing this data, and I will pull up some Excel data so we can look at the moving average. Okay, this is your homework assignment. I'm going to pull it up. Okay, so this is data on gas prices, weekly gasoline prices, okay? And this data goes from 1993, April 1993, to 2009, about 874 points of data. So let us say I want to look at a 4-week moving average. So what is the 4-week moving average? And I'm going to say 4-week moving average, okay? And so I'm going to take an average from April 5, you can see it's weekly, April 5, April 12, April 19, April 26, May 3. So this is week. So a 4-week moving average, you need to take 1, 2, 3, 4. You can take a 2-week moving average, but I want to look at a monthly moving average. That's what I want, because I want to see what happens over a month, okay? First of all, to explain to you why we are very much interested in, I'm not going to take all of it. Why we're interested is, let's look at this data, okay? I'm going to move the chart. All right. You can see here there's quite a bit of fluctuation, and I want to show that fluctuation a little bit better. So I'm going to format the axis. And the minimum, I'm going to put at 50. Okay. I'll move the minimum a little bit more. Put that 90. All right. What do you observe? You can observe a lot of fluctuation. You see that?
Yes.
Hello? Okay. You can see the fluctuation that goes on, even though what do we have? We have a long-term linear trend, okay? The secular trend is going up. That's what you see. The secular trend is going up. Nevertheless, within each time period, you can see fluctuations going up and down, okay? And you can see also that at some point, there was a linear trend going down, and then begins to go up again. So if you draw a line here, you're going to see a line that really does not give you very accurate information. So I'm going to stop this here and continue to discuss the PowerPoint first, and then Okay, so we have a moving average. So let me again, go back to illustration of moving average. This was my intention. Gas price. Okay. All right. So let's go back and explain the gas prices once more. So now let's take a 4-week moving average. So we take April 5, 12, 19, and 26, and we simply get an average. Okay. So I'm going to say equals average B2 to B5. B2 to B5. All right. So I have an average. And then I'll just drag this, and it's going to, I'm going to stop there. Okay. And so what do we have? What we have is another set of values that we can plot. I'm going to take those values here. Then all right. All right. Okay. So I'm going to all right. So now what I'm going to do, so I'm going to take so what have I done here? What I have done is to take the original data, and I'm going to plot the original values with the moving average values, just to show you. All right. All right. So what you see here, that when you take the moving average and plot it against the original data, you get a smoother curve, okay? And the moving average kind of follows the original data. And the more you learn about smoothing techniques, uh, the better you can use time series data, okay? But what I'm trying to explain to you is to show you how the moving average mimics the original data. Nevertheless, the moving average data is smoother. Okay, the moving average data is the blue line, and it comes out smoother and has less fluctuation than the original data. You can see here, all right? Okay. So again, I try to make the data clearer. So I'm gonna stop this share for now, but I will upload everything up later so that you can see what we're talking about. So I'm gonna continue with the PowerPoint. Okay, so moving average is simply a way to smooth out time series data so as to minimize the issues that arise from the fluctuation, okay? And you can use, this example says 3-year and 5-year moving averages. Suggest that you do like compare a 4-week moving average with a 2-week moving average, even a 10-week moving average, or even a 12-week, because 12-week is 3 months. Because you want to see how you smooth out the data over a period of 3 months so as to reduce the fluctuations, okay, and be able to make better decisions, okay? Now, there's something called weighted moving average, which we will not undertake here. The weighted moving average simply gives weight to the data, and then you use it to compute a moving average. But now, the whole idea is that when you are doing a weighted moving average, you apply a greater weight. The sum of the weights must be 1, for example. And I'm going to give you an example here, okay? I might use an actual data, but here is the idea. Let us say that you want to do a 4-period moving average, okay? You want to do a 4-period moving average. What you do is you assign, say, 0.5 to period, to the 4th period, and then you assign, say, 0.2 to the 3rd period, and you assign, say, 0.15 to the 2nd period, and then assign the balance to the 1st period. The sense that the more recent period is assigned a greater weight, but the sum of the weights must be equal to 1. You cannot make the sum of the weights greater than 1. The sum of the weights must be equal to 1. And so the whole idea is that more recent events, or the more recent time, reflects the more recent characteristic of the data that you are trying to weight. For example, your behavior, let's say the price of oil if you're looking at, say, 3 years, 2023, 2022, 2021, and 2020. The price of oil in 2023 reflects more of the thinking of the market, of really what is driving prices, than 4 years ago or than 3 years ago. That is the whole idea. This is why you give a greater weight to the more recent period, all right? All right, so now smoothing with a weighted average is usually better than just smoothing absolutely by giving every period equal weight, but we are not dealing with weighted moving averages. I could get into it, but we don't have that kind of time at this level of class. So now, as we talked about time series data, you can see we have the linear trend, which gives you the secular trend of the data. And you ask yourself, what is the rate of change in the trend? Okay, the rate of change in the trend. So let's see if we can get back to all right, you can see that this data here, you can see the line here that goes through the middle of the time series data, okay? Now, this is the raw data. Nevertheless, you ask yourself, what is the rate of change? How much for each time period, how much does the data change? Okay, so we use a linear regression model to estimate that trend, that rate of change. But as we're talking about how to deal with time series data, it is so much better to use a moving average to estimate and get a more accurate estimation of this rate of change, okay? But besides that, you also want to find out if the data is stable, if the fluctuation is stable, and so it gives you a more accurate data. So this is what we are going to talk about next week. This is where I'm going to estimate a linear trend, and we test for autocorrelation. And after we test for autocorrelation, we may try to correct for that autocorrelation and re-estimate the linear trend. In that way, we get a more accurate information, okay? So for now, I'm going to stop it here because now we're going to get into a topic that I would like to spend a whole period on, okay? So we use the least squares method and do an estimation, but I'm actually going to do an estimation using Excel. I'm sorry, using SPSS, okay? But I'm also going to use Excel. So when you estimate a linear trend, you get a constant and you get a slope, okay? You get a constant like any linear regression model, and you get a slope. So this slope here, this 0.15 times t, actually reflects the rate of change for each period of time. It could be for each week, it could be for each year, it could be for each month, it could be for each day, okay? It could even be for each minute, depending on the kind of data that you're dealing with, okay? So, but we also try to use other methods for estimating that trend. For example, we could use a log method. That is, we actually calculate the logs of each of the values, including the log of time. Okay, I just love using the log method. Okay, to estimate the rate of change. But now the log method would actually give you a percentage rate of change rather than a direct rate of change. So I'm going to hold it here. And then if you have any questions, you can ask questions. This might be the time to ask questions about your final. Your final is going to be a combination of multiple choice questions and also problem-solving questions. So that's simple. And the exam date will be during the week of the final exam. But I'm going to make an announcement as to the exact days that the exam will be available. All right? Are we okay?
Yes.
Okay. All right. So I'll see everybody next week. So be prepared for another lecture, all right?
Professor, quick question.
Yes, sure.
Do you know the name of the textbook that you're getting these chapters from? Like the week before last, we had one on index numbers. Now we have this chapter on time series.
Oh, okay. But I posted some readings.
Yeah. I just want to know what textbook they're coming from, so that way, if I want to go in further, point
I know the name of the textbook. The name of the textbook
Or maybe
is
you
there.
could recommend something at some point.
No. I mean, it's there. What I could do is I could download that particular chapter of the textbook. Let me see.
No, I mean, we have it. You gave it to us.
Yeah, this is from Lind.
That's the author, right?
Yeah, the author is Lind. But I will, this is the PowerPoint slides for the book, but I'll see if I can get a chapter, an actual chapter from Lind, and post it for you.
Oh, okay. Thank you.
All right?
Yes, thank you.
All right.
Professor.
Yes.
I have a question about the final. What is there? Would the multiple? No, not the multiple choice. The problem solving will all be within the quiz as well.
Well, no.
The
It will be a
final.
separate. You're gonna have 2 tests.
Oh, 2 tests.
Yes.
Okay.
I don't like embedding problem-solving questions inside multiple choice questions. I mean, that's just my attitude.
Okay.
Oh, so we'll be able to do the exam and then upload it?
You will answer the questions right there in the system.
Okay. Got it. Thank you.
Okay.
All right. Thank you, Professor.
All right. Have a good evening.
All right. Good evening.